Kia ora te whānau. Nā mai haere mai, welcome to this, our start of term 4. I hope you're all doing okay. Just let me know in the chat if the sound is coming through okay, and we'll be ready to dive into our first topic this term, which is going to be having a little bit of a look at investigations. So I'll just check over in the chat, make sure everything's coming through all good. Kia ora Jana, kia ora Una, kia ora Tim, kia ora Anjan. So our goal for this term is to review some of the concepts that we've been learning about this year. We're also going to have a last little chance next week to do a final investigation. Now that's going to use the same skills that we've been using basically throughout the whole year. So we're going to refresh those and make sure that we've learned some things over the course of the year. Additionally, in this first particular part of this week, I'd encourage you to look over any of the parts, particularly in the physical world topic that we just went through, that you might have found challenging. If there are anything that you actually, even if you go back to the notes or even if you go on Education Perfect, you're still struggling with it, feel free to send me an email or to chat to anyone else in the class, or even just to bring those questions to our Google Meet later this week. I'm more than happy to chat with you with the whole class or to chat with you one-on-one afterwards. All right, kia ora Nicholas as well. I can see we've got a number of us in here. By the way, team, if you join a little bit later, just fire off in the chat and I'll mark you as present. All right. Additionally, if you're coming to this at a later stage, it's recorded, so you can review this. You can always skip back to the start, all of that sort of thing. Again, I'm sorry about our technical problems that we're having on Google Classroom that mean that we can't load the classes into your calendars for you automatically. If I could do something about that, I would. Unfortunately, it's a known bug. The only solution is really to reset the entire Google Calendar, which means the entire Google Classroom being reset as well. It's like you're going to bring a whole bunch of challenges for all of you in terms of accessing the material. So that's why we haven't done that. All right, let's dive into our content for this week, which is reviewing the scientific method and all those kind of bits that come into it when you're doing your own investigation. So we've got 4 lessons in here. The last one's basically just going to be some stuff in our Google Meet, which we'll do later this week. The 3 lessons worth of content which are contained in the slides here look at all those aspects that you need to be proficient at in order to really nail your investigation. The other thing I should say, I forgot to mention this before, is that you all did an amazing job of updating your PC tasks. I'm just going to get those moderated later this week, and then hopefully get those grades to you pretty soon. Your grades will only go up. We'll take the best one over the course of the year, so don't stress too much about that. I will give you an update when I can. All right. Let's dive into our first topic, which is going to be on the scientific method. That's all our fundamentals that we need to know about science. So the first thing, there's a task for you to do this week, is to have a little bit of a look at the investigating in science cell-wise stages. Now the cell-wise stages are there for you as a kind of scaffolded set of things to work on. And normally, if you're at a certain level, you get a certain grade, you can look at the level above and say, okay, this is the next set of things I need to be working on, right? And those can be broken down into the different sections. So there'll be some stuff in there which might be really useful to you, particularly if you're sitting at a grade and you're not really sure what you need to do to work on next. This will be the first thing to look at. Additionally, as we're going through here, feel free to fire away in the chat if you're able to. So yeah, by all means, like ask away any questions. Kia ora, Shreyan. I can see that you're here too. I'm sorry if the live chat's not showing up. You can always say hi to me in the Google what's it called, just say hi underneath. I can see a whole bunch of you have tagged yourselves there. I'm sorry that that's not working. That's okay. I'll still mark you as present. If you want to ask any questions in that comment section too, I'll flick back to it as well. I'm sorry that our live chat's not working. Don't really know what's going on there. If anyone is really technical, perhaps you can explain it to me at our Google Meet this week and we can make it better. All right, so subway stages. Take a little bit of a look at those. Spend some time, and that will hopefully give you a sense of what you need to work on next, right? In week 2, so this is just so you know what we're working towards. In week 2, we're going to do this big investigation. This is what we call a summative. So you have like formatives, which is where you form the perspectives on what we need to work on, and summative, in summary, right? It's what you do at the end. And this assessment is going to basically be like a freer version of the first one we did. You will be given some data. If we were in school, you'd be collecting the data for yourself, but we don't want to disadvantage any of you, so we'll probably give you some data and explain an experiment where we gathered some data. And then it'll be your job to interpret that data, make it into a graph, and then to use that to explain something. It'll be to do with a science concept. But we're not going to reveal it now. We're going to talk to you about it next week. Okay, so hopefully we remember our steps of the scientific method. Now, you can break these down in a number of different ways, but usually you start off with a question, something you want to answer. Proper scientists will do like a whole big literature review where they review essentially all the work of everyone else and then figure out, here's a question I want to ask. Once you figure out a question that you want to ask, you got to make sure that it's testable, make sure that it's something that you could do, and if it's a good question, you can then come up with a hypothesis. I think that if we do this particular thing in this particular way, this is the result that we'll see, right? Once you've come up with that hypothesis, you confirm the design of your experiment, what method exactly you're going to take, and then you collect some data. You then need to process that data. That might involve doing an average, it might involve making a graph, it might involve a whole bunch of different things. But you've got to make sure that the data you're presenting, right, the processing methods, make sense for the data you've got. So we do that data processing thing, and then we need to analyze it. We need to kind of delve into what is that data telling us. If we look at our data, we can then have a little bit of a kōrero about it, and when you can link those results, be it a graph or whatever it is that you've made, and link it to the science concepts that you think are at play. The last thing we do is then do a little bit of a conclusion, where we say our hypothesis was correct, our hypothesis was incorrect, and here's why we think it is. You also need to package it up into a neat little bow, which we call communicating. So you might turn this into an article if you're a real scientist and publish it in a journal. And when you publish it in a journal, it gets peer reviewed by a whole bunch of other scientists who scrupulously look over your work and decide whether they think it's good or not. And they might even give you feedback so you can make adjustments. At this level, we would normally do that in a booklet if we were at school, but we'll have an online version of this. So that's our fundamentals, the scientific method. If you're unsure about those steps or you want it presented in a different way, this is a great little video here from Mumu Math and Science. There's also a nice extra for experts video here. So this extra for experts video is pretty awesome in going into more detail on this. If you're a big science fan, I'd recommend checking this out. What we're going to do now is break down each of those stages so that you know how to develop your skills around each. Okay? So, firstly, the hypothesis. What is a hypothesis? It's what you think will happen based on your knowledge, right? And usually you want to inform this with your past knowledge. You want to say, I think this because. Here is the evidence that makes me think this will happen. Now, a gut feeling is good, but we'd probably prefer you to say, I think this will happen because here's my evidence to support my hypothesis. Now, what you might find is that your hypothesis is wrong. And that's actually a really good thing in science. Disproving your own hypothesis can be a really powerful piece of learning and helps us to understand our world better. So in the end, we're aiming to either prove or disprove our hypothesis, but you need to make sure that your experiment can be tested in that way. So your hypothesis should be something that can be provable or disprovable. You can also have inconclusive results, and usually you need to go back and then adjust either your question or the exact way you did your method so that you can find an answer to what's going on. Now there's some tricks to running a good hypothesis, which we're going to go over here. The key things are, we talked about this already, you need to be able to test it. And it needs to be something that's either true or not true, right? So there's a couple of examples here. So I predict the blue flame is hotter than the orange flame is something that you can test. You can go out and measure temperature using some sort of thermometer, right? A bad example would be something like I predict yellow is the best color, right? Because that's not easily testable, right? You could predict something like I think most people of this age group like the color yellow, and then you could go test it by asking those people and measuring that. But the key thing here is it's about a good hypothesis is something that can be proved or disproved, something testable. Then we have our aim. Now, our aim is our explanation of exactly what we are going to be doing by the experiment, right? Our hypothesis is what we think will happen as a result. So our aim is always to do a fair test, something that is a good piece of science that answers our question accurately rather than not accurately reflecting the thing that we want to test, right? Normally in science, we try and change one variable because if we change one variable, we change one thing, it's easier to see the downstream consequences. You change, if you change a whole bunch of variables at once, it becomes much harder to see the implications or to see what's causing it and then explain it in a scientific way. They have a nice little sentence starter there for you to investigate the effect of. There's a nice sciencey way of introducing it, but also what you're interested in is the effect of something on something else. How does this cause this? That's what we're after. Now, titles can be a bit of fun. This is where you can really show your fun here, if you'd like to. Titles normally can spice things up, and you kind of supplement that with an aim. Sometimes people put kind of a supplementary title where they give the kind of full thing, but you can come up with something fun that sums up your explanation. The key goal is to engage your audience and make sure that they're ready to learn about whatever it is you're going to teach them. So we've got a couple of different examples here, which all link together the aim, the title, and the hypothesis. Sometimes students get these around the wrong way. That's why it's important to kind of introduce these. For some of you, you might be like, that's easy, in which case, that's good. You're ahead of the game. All right. You can have a bit of a practice with these three here. So what we'd encourage you to do is on the slides, have a go at writing the aim, the hypothesis, and the title. If you do that kind of practice, it's going to be really easy for you to bust this out next week when we give you the experiment. Okay. The next thing is variables. Now, I used that word before. A variable is something that can change, right? In science, we try and change one variable at a time so we can understand the implications or what will happen downstream as a result of tweaking one thing, right? So in all experiments, we try our best to make sure that we can only turn one of those variables at a time. Now, let's go through some examples of different kinds of variables. So we've talked about these before. Hopefully this will ring some bells. We have the independent, the dependent, and our controlled variables. So in an experiment, you pick the one thing you want to change. The thing you want to change is called the independent variable. The other thing is the thing you measure, right? The variable we measure. We call that the dependent variable because it depends on our independent variable. Everything else we're going to try and keep constant. We're going to try and control it, hence the term controlled variables. So controlled variables will be everything else in the experiment. In a good experiment, everything will be super well controlled. We'll be changing one thing and measuring one outcome. That would be an example of what we'd call a fair test, right? Not all tests are going to be fair. Some are going to be fairer than others, but it's our job as scientists to do the best we can with the resources we've got. So we've got an example of this here, right? Where you've got an experiment to look at which brand of fertilizer is the best to grow our strawberries. Your independent variable would be what fertilizer you pick, right? That's the thing you change. For one batch of strawberries, you give them fertilizer A. For one batch, you give them fertilizer B. The dependent is the thing you measure. Now, that could be the number of strawberries on the plants. You could equally have picked something like how tall the strawberry plants grow, how much all the strawberries together weigh. You can pick what that is, which is pretty neat. In this experiment, though, and the one we gave you next week, we will give you these to an extent. But when you're designing your own experiments in future, you can pick these, and you can pick what you think makes the most sense. The last thing is we've got to control everything else. Keep the amount of sunlight the same. Keep the amount of water the same. Keep the amount of seeds we're planting the same. Keep the exact species of strawberry the same. Because if we modify those things, maybe that's going to be the cause of our difference rather than our independent variable. So if you want some examples of like more kind of detail on this, you can have a look at this video here. A little bit of Mahi Kāinga for this is a little Quizlet, and then to have a go at that variable worksheet. Now that variable worksheet will be a good way for you to practice identifying the independent, the dependent, and what variables you need to control. And you remember when you did this earlier in the year, right? You had to say, here's the thing that I'm changing, here's the thing that I'm measuring, and here's everything I'm keeping constant. One last thing about variables, you always got to use units, right? How many strawberries is the number of strawberries, right? What type of fertilizer is a category, right? But if it was water, right, the amount of water you were giving the plant, you wanted to look at how big the strawberries got, you'd have to measure that in some way. Maybe it's cups, maybe it's milliliters, whatever it may be, but you have to be consistent. So now that we've done that, we're going to look at our second part of our topic today, which is on our methods and our graphing. Okay, so for this, we've got a little bit of an intro here. Independent, dependent, and control variables. This was looking at, water and plant growth. Who would have thought about that? You're welcome to pause the video here and have a little bit of a think about how you might answer these, because I'm going to reveal them in a second. Okay. If you just want to continue through with me, though, let's have a little bit of a look. How would we do this? Well, our independent variable would be the amount of water we give each day, or each week, or whatever it may be. And we give a unit for it. We say we're going to use milliliters. You could have said cups. You could have said teaspoons. Whatever it was, that's okay, as long as you've got a unit. We're then going to measure the dependent variable, which is how tall the plant grows. And we're going to use centimeters or millimeters or meters or feet, whatever it may be. And we'd think, okay, we'll be using a ruler for this, right? Lastly, we're going to keep all these other things controlled. What are the sorts of things we're going to control? We're going to control the amount of sunlight, make sure that's the same for every plant. We're going to control the amount of seeds we plant. We're going to control the temperature, right? We're not going to have some of our plants at my house and some of the plants at a mate's house, because they might be different temperatures. You know, there might be different levels of humidity, which is how much water is in the atmosphere, right? So, having a think about that. Now we're moving on to methods. Methods are pretty similar to recipes, which is what cooks use to figure out how to make something. Methods tend to be quite precise, right? So it's kind of more akin to baking. So if you like baking, you'll like writing good methods. It's a set of logical instructions that is clear so that somebody else could follow them, right? If you think that a mate of yours in the class couldn't follow your set of instructions, then it needs to be made clearer, right? And so we've got an example here of a nice little investigation, but you can see how this person has laid out their methods. They've used a numbered system, which you can use. You can also write it as a paragraph. I always found numbers easier to use, though. And they've gone through, here's what you do, then this, then this, then this, then this. And they've been super precise about it. Now, the reason why you've got to be super precise is because of things like this. Now, I just want you to fire off either in the chat, or if the chat's not working, you can comment under our class post, because I'm looking at that there. Did we do the peanut butter sandwich experiment in class? Let's give you all a moment to respond. I'll reload our class tab, just in case we can't see it. So yeah, I'm not entirely sure if we did this experiment with you. Okay, so that's okay if we didn't do this. This will be a fun little video for you to watch then. I'd encourage you all to watch this. This is a classic little experiment we do. I definitely did this with my Year 13s, and they did a terrible job with their methods. So have a little bit of a watch of this in your own time. I'm not going to spoil it. But essentially, the dad says to the son, please write me a method for making a peanut butter sandwich, or a peanut butter jelly sandwich. And the son's method was not quite precise enough. So have a little bit of a watch of that at some later point. But to answer these questions, you could probably watch that video and that will help you out. That extent. It's important to have detail because we need to be really precise so it's easy for other people to follow. There are a variety of different things you can do. Using exact numbers and units can be really helpful. Breaking down instructions so they are more easy to follow. Any of that sort of thing. Using a numbered sequence so it's easier to follow your method. All of that sort of thing can be really helpful for allowing other people, when you're coming up with methods in future, to follow the work that you've done. Now, the back half of this lesson is about graphing. Now, graphing is a skill that you work on. The more you do it, the better you get at it. Now, graphing is going to be a little bit hard online. So we will have details on exactly how we'd like you to produce the graphs for next week. But the rules still apply. And we kind of went through this as a class. So we need to give our graph a title. We need to use pen and pencil and rulers if we're doing this on paper. We need to make sure we label our axes and give them units. Our axes are our lines that go like this and like this, right? And we need to make sure that the scale that we pick starts at 0 and makes sense, right? We don't want some weird graph that's like really skinny and really tall. We want something that kind of fills the space so it's nice and easy to see. Now, on our graphs, we only tend to put our averages, the reason for that being that you want to look at the point of a graph is kind of to show how, on average, things, the one variable affects the other. Because there can be all sorts of little minor things that mean that there's difference in it around each point. And we also want to do a thing called drawing a line of best fit. A line of best fit is exactly what it describes, right? Break it down. It's a line that best fits the overall trend of where the data is going, right? At this level, our lines of best fit are all going to be straight lines, what we call linear lines. At higher levels, you can start to do all sorts of curves and funky things. We don't need to do that at this stage. We will be working up to it. I can assure you of that. The skill for this is you want an even amount of error, right, on both sides. So your line is never going to be perfectly straight and go through all your points unless you've done the best experiment in the world, right? But this is real life. You're always going to have a little bit of variation. So you've got to try and make sure that the amount of error, the amount of points above and below the line, are about equal, and that the distances of those points have a proportionate effect. So we'll show you an example of that in these slides here. So here, this is mostly pretty good, but the big problem here is that they haven't done a line of best fit. They've just joined the dots. Everything else about this is actually pretty good, right? So if you want to have a look at an example, take a look at this one here. Here on the right is a really nice example of a line of best fit, right? The student's drawn a nice line that kind of describes, on average, where those points are located, right? And what they can see, this is from a particular experiment where they looked at how the temperature of the globe increased over the course of their great-grandfather's life, and they plotted their great-grandfather's age by the temperature of the Earth, and they had a nice linear trend here. And then, actually, for those of you who want to do this kind of expert stuff, you can describe this in a mathematical way, where you can look at how, as this increases, how does that affect the temperature of the Earth, right? Which is quite a neat one. So, if you want to look at what Year 11s have to do for this, which I think some of you are capable of looking at, there's a nice Extra for Experts video on how to do that. If you're feeling like you're up for the challenge, that's there for you. You don't have to do that, right? At this level, we want you to be having a go at producing a graph with all those kind of features, these ones here, and then having a go at a line of best fit. So here's a little space for you to write a better method than what that kid does for the peanut butter and jam sandwich task, and a little task here about graphing, right, to get some practice in. Now we're on to our final lesson for today. Our final lesson for today is going to be on writing the conclusion and discussion, right, which is that kind of big texty section at the end of the report. So let's have a little bit of a look at this. So firstly, how would you describe the trend in this data? This is a little bit of a practice. We're going to pause the video here. I'll reveal the answer in a second. Essentially, the way that we write it is we use the terms increase and decrease, right? So the data shows that as the temperature of the house increases, the monthly cost of paying the power bill increased as well. If we look at that here, as temperature increased, temperature of the power bill increased as well, which is interesting. And for example, at 12 degrees Celsius, the monthly power cost was, and this would be, if you're into maths, you could actually calculate it mathematically, or you could approximate it by having a look at that value on the graph there, right? Now, the last thing with regards to this is correlations. So correlations are a nice little thing that come up in maths a little bit later on. So with graphs, if the graph looks like this and it's going up, right? If the graph is going up, we say that's a positive correlation. As our x value goes up, so does our y value. We would say if it's going the other way, right, like this, we would say as x increases, y goes down. That's a negative correlation, right? As this one goes up, this one comes down, it's a negative correlation. If the two don't look like they're related, so it's really hard to draw a line between them, we'd say there's no correlation, right? Or if, in particular, if the line is completely flat, we'd say as this thing increases, this other one doesn't change. Maybe they're not related. So those are kind of our 3 words for correlation there. So this is kind of how you describe the trend of some data. And this is kind of the basis of a conclusion, is to kind of put that information together. Excuse me. Once you've done that, you can decide whether this what you found supports your hypothesis or doesn't. Maybe in the case of so here's an example here. The time the water is exposed to the Bunsen burner flame, over time, you might see that the temperature of water increases or decreases. Now, your hypothesis might be here that if you leave the Bunsen burner flame on for longer, you have the water sitting on top for longer, the temperature of the water increases, right? You might do this example and then find that you produce a nice positive trend. So as the time the water is exposed to the Bunsen burner flame goes up, the temperature of the water also increases, right? To which you would say the data shows that as the time the water is exposed to the Bunsen burner flame increases, the temperature of the water also increases. You put in an example here, that would be a positive correlation, because as one goes up, the other one goes up too. And then you would say, this supports my hypothesis. I had the hypothesis that this would happen, and that's what we saw in the data. So that's what kind of that last section is for here. Now, as we get on with doing science, we will be able to start writing our own conclusions, and we won't need the scaffolding, but that's there for you at year 9, so you can kind of get used to that sciencey way of writing and using specific terms. So yeah, now there's some kind of this is kind of an example of how to do that, and we will give you that scaffolding when we give you this assessment. The next thing you'll be asked to do is to talk about how good your method was, right? And if you have a go at that that peanut butter and jelly sandwich task, you'll be able to look at how good or how bad your method was. So you can answer these sorts of questions and start talking about these sorts of things. Was your method a fair test? Do you think it was very accurate? Do you think it was very precise? All of that sort of thing. And once you've had a little bit of a think about that, you can write, yes, I thought we did a good job, or no, I don't think we did a very good job. Here's how we could have done it better. The next thing is to talk about the science, right? You want to talk about how the science relates to the two here, or relates to your experiment. So if we're taking the example of the Bunsen burner heating up some water, you remember that as you heat up molecules, they shake more and more and more and more, right? And that as that occurs, you have more vibrations of other particles as well, and through conduction, convection, and radiation, heat is passed from one place to another, and so the heat from the Bunsen burner gets transferred to the water. The longer it's on that Bunsen burner flame, the more heat energy is then in the water, so therefore the higher the temperature will be. That would be, if you wrote something like that, that would be an example of you talking about the scientific reasons for what you saw, and there'll be a space in the report for you to do that. Now we want you to kind of relate it to the things you've already been learning. We're going to try and not give you experiments that don't rely on things you already know. So we want you'll already know a lot of the science behind this stuff. So you're welcome to refer to your notes when you're putting this together to help you to be able to answer these questions, right? Lastly, there's a section here called further investigations. Further investigations are, what questions do you now have now that you've gone through this experiment? Usually, a great piece of science will leave you with more questions to answer, right? What happens if we did this Bunsen burner experiment but with Powerade? What happens if we did it with ice instead of water? What happens if we did it with a gas? What happens if we did it with chocolate milk? Whatever it may be, right? So those are the sorts of questions that you can then ask. You can say, this has got me thinking about these things. What that really demonstrates to us is that you've thought critically about this experiment and that you've thought about what the implications will be in future. So here's a nice little example of an experiment, and it probably gives you some ideas about what to think about next, which is quite cool. Okay, there is a nice little thing here about skepticism. If you want to have a look at that, but it's not required. The last little thing is, here's the space for you to put your coconut and any new method you might want to put in here. But this is an options task, so you can pick one of these two. The other thing you could do is have a bit more practice around discussing the science ideas, so you can pick whichever you want to most work on. Now I know that's a lot of work to be getting into, particularly at the start of this term. We're hoping that this sort of work will prepare you well for your investigations for next week. So don't be too nervous if you don't get through it all. Just work on the parts that you think you most need to work on and bring any questions that you may have to our Google Meet later this week. Okay? Now that brings us to the end of our lesson for today. I will stick around for another couple of minutes. I'm happy to answer any questions either on the classroom post in the comments there, or to answer them in the chat if you're able to get that working. All right? Thank you all very much for your attention. Just remember, you can always skip back to other sections in this to rewatch any parts that you think you need to go over again. I know I speak quite quickly, so that's okay. But it's been very lovely chatting with you. Look after yourselves, and I'll see you later this week.